Good morning, students. In previous class we have to learn what is the solution and what is the solvent and what is the solute and types of solutions. Now we will discuss how to concentration of solutions can express. So before this, what is the uses of knowing about concentration of solutions? For example, in our chemistry laboratory, two solutions are there. So one is 2 molarity of HCl solution and second one is 10 molarity of HCl solution. Now tell me, so which solution is safeful to our body and which solution is harmful to our body? So we can say that 2 molarity of HCl solution is safeful to our body and 10 molarity of HCl solution is very harmful to our body. So we can determine which is harmful or which is safeful to our body by the using of knowing about concentration of solutions. So number of uses are there for the information about knowing about concentration of solutions, but it is a one example. So now expressing concentration of solutions. The solution concentrations can be expressed either qualitatively, quantitatively. So that is a qualitative, but qualitatively we can say that the solutions are two types: dilute solutions, concentrated solutions. But what happened here? These terms cannot explain the solution either saturated or unsaturated or supersaturated. It can only explain dilute solutions as well as the concentrated solutions. But another way to express the concentration of solutions, that is quantitatively. So in quantitatively we can calculate the specific amount of solute is present in solvent. So there are number of ways quantitatively. First one is mass percentage, second one is volume percentage, third one is mass by volume percentage, fourth one is parts per million, fifth one is mole fraction, sixth one is molarity, and seventh one is molality. So these are the concentration of solutions can expressed in quantitatively. So now we will discuss about first mass percentage. What is the definition of mass percentage? The mass of solute present in 100 grams of solution is called mass percentage. Okay. What is the principle? W by W percentage equal to mass by solute is divided by mass by solution. Solution means here both solute as well as solvent both are present in solutions into 100. We can calculate the mass percentage. So it has no units. Okay, it is very important, as well as it is temperature independent. So because mass does not depend on temperature, that's why it is a mass percentage is temperature independent, is very important. Next, it is used in industrial process, that is a commercial concentrated aqueous reagents. Example, acids, bases are labeled in concentration of mass percentage. So generally we can see in fertilizer shops. So and that what is that fertilizer shops? That poisonous bottle having on that poisonous bottle, what happened here? Some concentration of solutions is represented in mass percentage. Okay, and next one is volume percentage. Sorry, what is the volume percentage? The volume of solute is present in 100 ml of solution is called volume percentage. What is the principle here? Volume of solute is divided by volume of solution into 100. So it has no units and it is a temperature dependent because the volume is depend on temperature. and it is used when a liquid solution is being prepared. And the best example, 35% of glycol is used as anti-freezing agent in car engines to cool engine. Whenever 10 ml of ethanol is present, 90 ml of water. So to calculate the volume percentage. So how much the volume percentage is given? This is a volume of the solute, where it is volume of the solute. Next, volume of the solvent. Volume of the solvent into 100, it gives the volume percentage. Next, mass by volume percentage. The mass of solute present in 100 ml of solution. So mass of solute is divided by volume of solution into 100. We obtain mass by volume percentage. But it has a units, those are gram per milliliter. So it is a temperature dependent because volume is dependent on temperature, and it is used in medicines and pharmacy. It is used in medicines and pharmacy. And next, parts per million. It is used for very dilute solutions. Very dilute solution means the solute is present in very small quantity. Okay, so what is the definition? The number of parts of solute present in total number of solution is called parts per million. It is used for very dilute solutions. So number of parts of solute is divided by number of parts of solution into 10 to the power of 6 means million. Okay, it is used to measure pollutant present in atmosphere or water. Okay, so general example, 1 liter seawater concentration is 5.8 ppm. ppm means parts per million. So this indicated that 5.8 grams of solute is present in 10 to the power of 6 parts of solution. Next, mole fraction, already we know. Sorry, the ratio between the number of moles of one component to total number of moles of solution is called mole fraction. So it is represented by chi. Okay, number of moles of solute is divided by total number of moles of solution. Sometimes it's represented x or chi. Binary solution. Binary solution means two components are there, A component and B component. Number of moles of Na is number of moles of A component and Nb is number of moles of B component. So now mole fraction of the component A equal to number of moles of component A is divided by total number of moles of components in solution. Total number of components, how many components are there? A and B. That's why Na plus Nb. Now component B is equal to Nb by Na plus Nb. This is the component of B as well as total component of the solutions. If a solution containing I number of components, what happened here? Xi equal to Ni sigma Ni. Okay, is very important. Sum of all the moles fraction, sum of all the mole fraction is unity always. That is x1 plus x2 up to xi equal to 1. Okay, next one, molarity. It is also we known the number of moles of solute is dissolved in 1 liter of the solution is called molarity. So it is represented by capital M. M is equal to moles of solute is divided by volume of the solution. What are the units? Units are mole per liter. It is a temperature dependent because volume is depend on temperature. Molality. The number of moles of solute is present in 1 kg of solvent. So it is represented by small m. Moles of solute is divided by mass of solvent in kg. So units are moles per kg. It does not depend on temperature because mass does not depend on temperature. Okay, so a small difference between the molarity and molality. In molarity, volume of the solution, solute is present in volume of the solution, but in molality, solute is present in solvent. And molarity is depend on temperature, but molality does not depend on temperature. So these are the major difference between the molarity and molality. Thank you. So now we will discuss some problems. So here, calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. Okay, so here 20% means weight by weight, that is mass percentage. Okay, so what happened here, 20 grams of ethylene glycol is dissolved in 80 grams of water. So now first, so mole fraction need moles, mole fraction need moles, so that's why. But here what is given, 20 grams is given, so first the grams are converted into moles because mole fraction needed moles. So what is the formula of moles? Number of moles is mass by molar mass. So now we can determine number of moles of glycol, ethylene glycol, or 20 grams. 20 grams is divided by 62 grams per mole. This is a molar mass of ethylene glycol. You calculate. Okay, you calculated, and the total molar mass of the ethylene glycol is 62 grams per mole. So now what is obtained here, 0.322 moles. Next, water, 80 grams of is divided by molar mass of the water. Okay, so 18 grams per mole. So now obtained 4.444 moles. Now ethylene glycol moles obtained, water moles obtained. So now mole fraction of the ethylene glycol. Mole fraction of the ethylene glycol equal to number of moles of ethylene glycol. Number of moles of ethylene glycol is divided by total number of moles of solution. That is, both are added. So how much we obtained? Mole fraction of the ethylene glycol 0.068. We know that what happened, all sum of all mole fraction is equal to 1. So now we calculated the mole fraction of water. It is a 1 minus mole fraction of the ethylene glycol. How much ethylene glycol mole fraction? So 1 minus 0.068. So now obtained mole fraction of the water 0.932. Next, calculate molality of 2.5 grams acetic acid in 75 grams of benzene. Molality is very important because what is here, the solute is present in solvent. So 2.5 grams are given, so here is also number of moles are required. That's why the grams is converted directly into moles. So number of moles, what happened? Oh, sorry, what is the formula of number of moles? Mass by molar mass. So how much the mass is given? 2.5 grams. The molar mass of acetic acid is 60 grams per mole. So now number of moles of acetic acid is 0.041 moles. Next, so here the benzene solvent is given in grams. That's why this 75 grams is converted into kg. So how much? 75 into 10 to the power of minus 3 kg. So now molality of acetic acid, the number of moles of solute, that is 0.041 mole, is divided by mass of solvent. Mass of solvent, how much? 75 into 10 to the power of minus 3 kg. So now the total molality of acetic acid is 0.556 mole per kg. What is the formula of molality? Moles of solute is present in mass of solvent.